Hello students, let us continue the session on understanding elementary shapes. In the previous session, we have learned some of the important concepts related to geometry. In today's session, we will continue the concepts related to triangles, polygons, and three-dimensional objects. To start with, let me consider triangles. First, we shall define triangles. Triangles is defined as a polygon with three sides. This is the polygon with the least number of sides. We classify the triangles based on the sides and angles. We shall learn the classification of triangles. Once again, let me repeat. Triangle is a polygon with three sides. It is a polygon with least number of sides. Every triangle is of different size and shape. We classify them on the basis of their sides and angles. First, let us learn the classification on the basis of sides. We all know that there will be three sides in a triangle. Out of these three sides, if all the three sides are different, it is called as a scalene triangle. If two of the sides are equal, then it is called as isosceles triangle. If all the three sides are equal, then it is called as equilateral triangle. A scalene triangle is one in which all the three sides are different. If I name this triangle as ABC, the side AB is not equal to the side BC, which is not equal to the side AC. If all the sides triangle are different, then it is called as a scalene triangle. Next, we have isosceles triangle. If I name the triangle as PQ and R, here two of the sides, that is PQ equal to PQ equal to QR. If two sides are equal, then it is called as isosceles triangle. Next in line, we have equilateral triangle. In this triangle, we have xy equal to xz equal to yz. All the three sides, they are equal to each other. This is all about on the basis of sides. Again, the triangles can be classified on the basis of angles. Based on the type of the angle the triangle has, we define acute angled triangle in which all the three angles are less than 90 degree. Right angled triangle. If one of the angle is 90 degree, it is called right angled triangle. Obtuse angled triangle. One of the angle is larger than 90 degree. Here, first one, acute angled triangle. If I name the triangle as ABC, here angle A is less than 90 degree. Angle B is also less than 90 degree. Angle C is also less than 90 degree. If all the angles are less than 90 degree, then it is called as acute angled triangle. Next, we have right angled triangle. If I name the triangle as MNO, in this triangle, we have angle MNO equal to 90 degree. If one of the angle of a triangle is 90 degree, then it is a right angled triangle. Next in line we have obtuse angle triangle. Here angle KLM is larger than 90 degree. If one of the angle of a triangle is obtuse, then it is called obtuse angled triangle. Angle measure will be more than 90 degree. These are the types of triangles. Next in line we have the next quadrilateral, which is having 4 sides. Quadrilateral is a polygon with 4 sides. There are so many quadrilaterals like rectangle, square, parallelogram, rhombus, trapezium, and also kite. These are different types of quadrilateral. We shall see few of the properties of each one of these quadrilateral. Let me take a rectangle. Observe this. It has got 2 pair of opposite sides equal. If I name the rectangle as ABCD, here AB will be equal to CD and AD will be equal to BC. Opposite sides are equal. Not only equal, they are also parallel. AB is parallel to CD, AD is parallel to BC. In this rectangle, we have all the angles measuring 90 degrees. A quadrilateral in which opposite sides are equal and parallel, and one of the angle is 90 degree, it becomes a rectangle. In detail, you are going to learn the properties of quadrilateral in class 9th. A detailed study on quadrilateral is done in class 9th. Now the basics you need to understand. Look at this figure. I have named the figure as KLMN. In this figure, we have KL equal to LM equal to NM equal to KN. All the sides are equal. Not only that, opposite sides, they are parallel. KL will be parallel to MN or NM. LM is parallel to KN. Opposite sides are parallel to each other. And the angle measures, angle K will be equal to angle L, will be equal to angle M, will be equal to angle N. Each of these angles is 90 degrees. What difference you can see in these two figures? In the first figure, we have got only the opposite sides equal. In the second figure, we have all the sides equal. That's the only difference between a rectangle and a square according to these two figures. There is another concept called as a diagonal, which you are going to learn in higher classes. You will learn that diagonals are equal and they bisect each other perpendicularly in square, and diagonals are equal but they do not bisect each other in rectangle. This concept related to diagonal you will all learn in higher classes, but then only the basics are there in class 6th. Look at the next figure, parallelogram. If I name the parallelogram as PQRS, opposite sides are equal and parallel. PS will be equal to QR and PS parallel to QR. PQ equal to SR and PQ is parallel to SR. Look at the angles here. These angles, they are not equal. In higher class you will learn that opposite angles will be equal. Angle P will be equal to angle R. Angle S will be equal to angle Q. Let's see the next figure. It is called as a rhombus. Rhombus and square, they are almost similar. If I name this particular rhombus as ABCD, in rhombus all the sides are equal. AB will be equal to BC will be equal to CD will be equal to DA. Opposite sides are parallel. AB is parallel to DC, AD is parallel to BC. Opposite angles are equal. As we have seen in parallelogram, opposite angles are equal. In this also opposite angles are equal. Angle A equal to angle C, angle D equal to angle B. Here there is diagonal which intersect each other at 90 degrees. Diagonal is a line segment joining the opposite vertices, and angle formed here will be 90 degree. These two parts will become equal. Trapezium. Trapezium is a polygon in which only one pair of sides will be parallel. If I name this trapezium as PQRS, PQ will be parallel to SR and other pair of sides, they are not parallel. Such type of figure is called as trapezium. In general, what is polygon? Polygon is a closed figure made up of 3 or more than 3 line segments. We classify the polygons on the basis of their sides and the vertices. Look at this. If the number of sides is 3, we get a triangle. If the number of sides is 4, we get a quadrilateral. And in quadrilateral we have seen different figures. Here I have considered only square. If the number of sides is 5, we get a pentagon. If the number of sides is 6, we get hexagon. You can count the number of sides here. 1, 2, 3, 4, 5, 6. If 6 sides are there, it is hexagon. If 7 sides are there, it is heptagon. If 8 sides are there, it is called as octagon. If 9 sides are there, it is called as a nanogon. If 10 sides are there, it is called as a decagon. If in general n sides are there, it is called as n-gon. Here I want to tell you another important concept called as regular. If you have a triangle in which all the 3 sides are equal, it is called as equilateral triangle. This is a regular triangle. If you have a square all the four sides are equal. It is called as a regular quadrilateral. If you have five-sided figure such that all the five sides they are equal to each other, then it is called as regular pentagon. So this word regular refers to all sides equal. Not only that, all the angles are equal. So a question arises here, what is the meaning of regular hexagon? What is a regular hexagon? We have learned hexagon refers to a six-sided polygon. A regular hexagon is one in which all the six sides are equal. Not only that, all the six angles are equal. Next we have three-dimensional shapes. Three-dimensional shape figures are also called as a solid shapes or solid figures. They are having length, breadth and height. Like cone, it is a three-dimensional figure. One of the example is ice cream cone. Cube, it is a four-sided laterally and two sides on top and the bottom. It is three-dimensional figure. Example is a wooden block. Cuboid, one of the example is a matchbox. Cylinder, one of the example is a glass or a cooking cylinder. Sphere, one of the example is a ball. Pyramid, in the rubric we have seen a pyramid shape. Egyptian pyramid is also a pyramid. What does a three-dimensional figure contain? It will be having faces, edges and vertices. You can see here I have taken a cuboid. A cuboid is a three-dimensional object. Look at this. The flat surface of the solid shape are called faces. In a cuboid, there will be six faces. The line segment where two faces meet each other, it's called as a edge. Count the number of edges here. 1, 2, 3, 4. 4 bottom. Totally 8 plus 2, 10 plus 2, 12. There will be 12 edges. The point wherein the two edges meet each other, they are called as vertices. Here you can count, there are totally 8 vertices. Vertex is a singular, vertices is a plural. There is a beautiful relationship between the number of faces, number of edges, number of vertices. This relationship is given by one of the great mathematicians called as Euler. The spelling is Euler and it's called as Euler's formula. The Euler's formula says F plus V equal to E plus 2. You can observe here there are 6 faces. 6 plus 8 vertices is 14. It is same as the number of edges plus 2. This relation holds true for all those figures where there exist faces, vertices and edges. This formula is not specified for spherical objects, and also like sphere, cylinder, cone, we don't have Euler's formula. Let us discuss the number of faces, edges and vertices in some of the figures here. In a cube, there are 6 faces, 12 edges and 8 vertices. In a cuboid, it is same, 6 faces, 12 edges and 8 vertices. In cone, we have got 2 faces. One of the faces is called as a curved surface, another face is called as base. There is only one edge and there will be only one vertices. And in sphere, we have got only one face, which is spherical, and the number of edges, we consider it as 1. And there is no vertices. In cylinder, we have got 3 faces, 2 edges, and 0 vertices. In a square-shaped pyramid, we have got 6 faces, 8 edges, and 5 vertices. In a triangular prism, we have got 5 faces, 9 edges, and 6 vertices. In a rectangular prism, which is same as a cuboid, we have 6 faces, 12 edges, and 8 vertices. With this knowledge, we shall solve few questions of the exercise now. I am taking exercise 5.1. Let's see the first question. The first question is, what is the disadvantage in comparing line segments by mere observation? By mere observation, we cannot absolutely sure about the judgment. We compare 2 line segments of almost same length. We cannot be sure about the line segment of greater length. Therefore, it is not an appropriate method to compare the line segments having a slight difference between their lengths. This is the main disadvantage. I'll write the answer for this in a short way. Comparing the lengths of 2 line segments simply by observation may not be accurate. So we use divider to compare the lengths of the given line segments. Suppose if you have one line segment, say AB, another line segment, say CD, if AB is say 5 centimeters and DC is 5.1 centimeter, just by observation we will not be able to say that which one is greater. So yes, the disadvantage of just observing, so comparison by mere observation is not correct. Second question, why it is better to use a divider than a ruler while measuring the length of line segment. Measuring the length of line segment using ruler, we may have the following errors like thickness of the ruler or angular viewing. Sometimes we may not view in a proper direction. So these errors can be avoided by using divider. Let's write the answer. Measuring the length of a line segment using a ruler, we may have the following errors. First error could be the thickness of the ruler. The second error could be angular weaving. These errors can be eradicated by using a divider. So it is better to use a divider than a ruler. Question number 3. Draw any line segment, say AB. Take any point C lying in between A and B. Measure the lengths of AB and BC and AC. Is AB equal to AC plus CB? Note, if A, B and C are the 3 points on a line such that AC equal to AC plus CB equal to AB, we can be sure that C lies between A and B. I'll tell another concept related to this situation. If many points are there on a same line, then those points are called as collinear points. They're called as collinear points. Let us consider a line segment AB. Roughly I am drawing a line segment AB. Let me name this point as A, this point as B. Let me take a point C somewhere between AB and let me take the line segment AB equal to 7 cm. C lies between A and B. Here AC, if you measure, we get some length. Suppose if it is 3 cm, you measure the length CB, this becomes 4 cm. Therefore, AB is 3 cm plus 4 cm, which is AC plus CB. Therefore, AB equal to AC plus CB. Here, A, B and C are collinear. We call the points as collinear if they are making a straight line. Question number 4. If A, B, C are 3 points on a line such that AB is 5 cm, BC is 3 cm and AC is 8 cm, which of them lies between the other two? We have AB equal to 5 centimeter, BC equal to 3 centimeter. Therefore, the sum AB plus BC is 5 plus 3, 8 centimeter. But they have given the length of AC as 8 centimeter. Hence, B lies between A and C. It is something like this. We have a line segment, say AC, which is 8 centimeter. We have the point B somewhere here, such that AB is 5 centimeter, BC is 3 centimeter. Together it is 8 centimeter. Understood? Let us take up the next question. Question number 5. Verify whether D is a point on AG. Look at the figure here. There are some letters mentioned over a number line. A is at 1, B is at 2, so on. G is at 7. From the figure, we have AG equal to 7 centimeter minus 1 centimeter. What is the reason? The reason is from 0 to 1, this is considered as 1 centimeter. A to G is AG. So this 1 centimeter to be subtracted from 7, we get 6 centimeter. So the length of AG is 4 centimeter minus 1 centimeter, which is equal to 3 centimeter. And DG is 7 centimeter minus 4 centimeter, which is 3 centimeter. Therefore, we have AG equal to AD plus DG. Hence, D is a point on AG, which is making equal parts, so I can say it is a midpoint of AG. Question number 6. If B is a point, midpoint of AC, and C is the midpoint of BD, where A, B, C, D lie on the straight line, say why AB will be equal to CD. For this, let me consider a line segment having the points A, B, C and D. B is the midpoint of line segment AC. Therefore, AB will be equal to BC. Let me call this as equation number 1. C is the midpoint of line segment BD. Therefore, I can say BC equal to CD. Let me call this as equation number 2. From equation 1 and 2, we have AB equal to CD. Here you can see AB is equal to BC, but BC is equal to CD. Therefore, AB and CD, they are equal to each other. Let us solve the last question. Question number 7. This is the last question of the exercise and also the last question for today's session. Draw 5 triangles and measure their sides. Check in each case if the sum of the lengths of any two sides is always less than the third side. I have brought some triangles here. First one, in triangle ABC, I have considered the sides AB to be 2.5 cm, AC to be 5.2 cm, BC to be 4.8 cm. The sum of the sides AB plus BC is 7.3 cm. It is obviously greater than 5.2 cm. Therefore, sum of two sides is greater than the third side. Another triangle PQR with PQ equal to 2 cm, QR equal to 2.5 cm, PR as 3.5 cm. Sum of PQ plus QR is 4.5 cm. It is greater than 3.5. So the sum of two sides is greater than the third side. I have taken the next set XYZ as a triangle with xy equal to 5 cm, yz 3 cm, zx 6.8 cm. The sum of xy plus yz is 8 cm, which is obviously greater than 6.8 cm. Hence, the sum of two sides is greater than the third side. Fourth triangle, I have taken triangle MNS with MN equal to 2.7, NS equal to 4, MS equal to 4.7. The sum Mn plus Ns is 6.7 and this is greater than 4.7. Hence the sum of two sides is greater than the third side. Last, I have taken the triangle KLM with KL equal to 3.5, LM equal to 3.5 and KM equal to 3.5. I have taken equilateral triangle. Let's see the sum. KL plus LM is 7 cm. It is greater than 3.5 cm. Therefore, sum of any two sides of triangle is larger than the third side. It cannot be less than the third side. So the conclusion is sum of any two sides of triangle never be less than the third side. The sum of AB plus BC is greater than AC. The sum of AC plus AB is greater than BC. The sum of BC plus AC is greater than AB. This condition is true for the triangle ABC. Similar, in any triangle, sum of two sides is always greater than the third side. Remember that. With this, I conclude today's session. Thank you.